Okay, let's take a look at an empirical formula problem. This is one of the most important problems that you'll see all year, namely because it appears on all three finals and on numerous other tests, so you definitely want to learn it as quickly as possible. A empirical formula is the simplest whole number ratio of elements in a compound, and I bet you probably talked about that in class, so we don't need to necessarily go over that. First things first here, we're given the percentages by mass, but we aren't given the amount of oxygen. So let's calculate that, acknowledging that the total percentages have to sum up to 100%. And we have a very specific protocol that we follow for empirical formula problems. The first thing that we do is we assume that we have 100 grams. Now, we don't always have to assume, or we don't necessarily have to assume 100 grams, but it makes the math easier. Notice here that the percentages become the grams of compound, and that's why we assume 100 grams. Some people will assume the molar mass worth of grams that's given in the second half of the problem. You get the same answer, but it makes it a little more complicated. So once we have these amounts and masses, we know that the empirical formula is the ratio of moles between each element. So what we're going to do is convert the grams of carbon, the grams of hydrogen, and the grams of oxygen to moles. And obviously we've done that before, so this shouldn't be too complicated, and we don't necessarily need to go over that. But again, dimensional analysis is our guide. We put grams on the bottom, and we use the molar mass of the elemental value here. So in other words, we use the molar mass of carbon, 12, hydrogen, 1, and oxygen, 16. Now, the actual empirical formula is going to be the ratio of moles. So we're going to divide by the lowest number here, which in this case is 3.41. And again, this is sort of step 3, if you will. Step 2 is converting to moles. So we're going to divide by 3.41 to get our initial ratio. And this is actually a more difficult empirical formula problem than one that you're probably going to see on many tests and quizzes, namely because this value here is not an integer, or not close to an integer. If this were like 1.05 or 0.95 or 2.202, excuse me, we could round that to 2 or the other integer values that I discussed. 0.34 is way too far from 1 for us to round that down to 1. Notice, however, it looks suspiciously like 1.33. So here you have to use a bit of your imagination. And as a general rule, if you see any decimals that end in 0.25 or 0.33 or 0.5, 0.66, 0.75, you're going to recognize that as a common fraction. And 1.34 looks a lot like 4/3. Again, this isn't necessary in many of the empirical formula problems that you'll do. We're showing you the most difficult one here just to prepare you for ones that you might see. So acknowledging that this is probably 4/3, we can eliminate the fractional value here by multiplying by 3. So if we multiply everything by 3, we get 3 to 4 to 3. And you can see that there. So accordingly, we're going to argue that our empirical formula should be C3H4O3. Now, we actually want to think about what possible molecular formulas we could have. It could be the empirical formula, C3H4O3, or any integer multiple. It cannot be C4H6O5 because that's not an integer multiple. So it could be C6H8O6, C9H12O9, etc. Fortunately, we're given the molar mass, and we're always going to be given this in the problem. So basically, we want to look at what the molar mass of the empirical formula is and compare that to the given molar mass. So here, what I'm going to argue is the amount that we need to multiply the empirical formula by should be the ratio of molar masses of the molecular formula to the empirical formula. So if we have the empirical formula of C3H4O3, we calculate the molar mass, and we see that it is 88 grams per mole. Notice already right off the bat that this looks suspiciously like half of 176. We have to double 88 to get to 176. And in fact, the ratio is in fact 2. So what this means is that the actual molecular formula should be double the empirical formula. And as a general rule, you should always get an answer that is close to an integer value. So if I got a ratio of 1.5, I wouldn't multiply the empirical formula by 1.5. That instead would tell me that I've probably done something wrong in the empirical formula calculation, and I'd have to go back to that point. So the ratio of molar masses between the molecular formula and the empirical formula should be very close to an integer value. So this is probably the most difficult empirical formula problem we can give you. Good luck.